Welcome to the Tech Egg. Don't get scrambled. Enjoy the video.
You start by verifying hardware and driver compatibility. Know your GPU model and which CUDA/cuDNN versions it needs, because mismatches break runtime. Once you have that, install the Nvidia driver, then the specific CUDA toolkit and matching cuDNN libraries. Next, create a clean Python virtual environment, upgrade pip, and install the TensorFlow build that targets GPU support. Make sure binary and library paths are exported, so the runtime can find CUDA and cuDNN libraries when loading. Now configure the runtime environment so TensorFlow can talk to the device. Export path and LD library, path to include CUDA bin and lib directories, and verify NVCC is callable. Install optional helpers like NVIDIA MLPy3 to inspect device status. Then run a short Python snippet that lists physical devices and performs a tiny GPU-backed operation. For example, a 1024 x 1024 matrix multiply on a TF device/GPU. To finalize, configure TensorFlow GPU options. Enable memory growth or set an explicit memory fraction so your process doesn't reserve all GPU RAM. Use TF. Config. Experimental. Set memory growth. Then run your real workload and monitor with Nvidia SMI. If you encounter failures, first inspect driver and CUDA/cuDNN version mismatches, verify LD library path, and confirm kernels loaded. Troubleshooting tip: if TF. Config. List physical devices, GPU returns empty, reboot after installing drivers, and recheck environment variables before deeper debugging.
Thanks for watching. Consider subscribing if I helped unscramble your problems.